Today's lesson, we will be solving logarithmic equations. So I'm going to do 6 examples. You can kind of see a variety of these types of equations. So let's start with 6 plus 2 log, it's a common log, so base 10 of 5x equals 18. I think students like these types of equations because it's just kind of solving for x. We like the system and the rules. We need to isolate this log, subtract 6 on both sides. So 2 log of 5x equals 12. The 2 out in front, we could just divide both sides by 2. So log of 5x equals 6. And now once the logarithm is isolated, we can convert it to its exponential form. So base 10 to the power of 6 equals 5x. So 10 to the power of 6, and then we'll divide by 5. And you should get that x equals 200,000. Now, when you are solving logarithmic equations, one thing you have to do is often check for extraneous solutions. A reminder, an extraneous solution is, hey, we did all the math correct, we got an answer, but when you plug it back in, it doesn't work. It will be something that is not in the domain of a logarithmic function. But in this case, it works. It will check. So we're going to move on to the next one. Example 2. Log base 4 of x equals log base 4 of 3 plus log base 4 of x minus 2. Okay, so this one looks a little bit more complicated, but product of logarithms, we can combine that into one logarithm. So log base 4 of x equals log base 4 of, we're going to do 3 times x minus 2. So I'm going to go ahead and just distribute that right away. So 3x minus 6. Now these ones are kind of nice. When you have a logarithm on both sides and they're equal, then that means this part has to equal this part. X has to equal 3x minus 6. And then we just have to solve for x. So subtract 3x. Negative 2x equals negative 6, so x equals 3. Okay, next example is similar to the last one, but we're going to use natural log x plus 2 plus natural log 3x minus 2 equals 2 natural log of 2x. So it's similar to the last one, just in the sense of properties of logarithms. We can multiply here and here together. But multiplying 2 binomials, we're going to have to FOIL and get a quadratic. So this would be the natural log of, if we FOIL that, that would be 3x squared, and then plus 4x minus 4. And then another property of logarithms is this 2 could become a power. So ln of 2x squared. So if you have a natural log isolated on both sides, and if these are equal, then therefore this has to equal this. So I'm going to write 3x squared plus 4x minus 4 equals, I'm going to write this as 4x squared. So to have a quadratic, let's set it equal to 0 and see if we can factor it. So I'm actually going to bring all of these terms over so that my leading term will be positive. So 0 equals x squared minus 4x plus 4. So to factor it, we'll have x minus 2 times x minus 2. So therefore, x equals 2. Now, you might not have room on your notes, but I do want to go through the checking process on this one. So I'm plugging in 2 back into the original function. So let's see, ln of, I'm plugging in 2 for my x, 2 plus 2 plus natural log of 3 times x, which is 2, minus 2, equals 2 natural log of 2x, so 2 times 2. So natural log of 4 plus natural log of 4 equals natural log of, let's see, 2 times 2 is 4, and then square it, so that would be 16. Property of logarithms would show that we would multiply those, so natural log of 16 equals natural log of 16. Oops, I don't know why I wrote 16 twice. So I just wanted to show that process that, oh, this does check. Extraneous solutions often do come up when we're dealing with quadratics, but in this case, it worked. Okay, so the next one, guess what? We're going to find an extraneous solution. So let's go through this process again. Log base 12 of 12x plus log base 12 of x minus 1 equals 2. So I don't have a logarithm on the other side. What I'm going to do, property of logarithms, I will condense this by multiplying. So log base 12, I have to do 12x times x minus 1. So I'll distribute and get 12x squared minus 12x, and this equals 2. So now when we only have logarithm on one side, that's when we convert it to its exponential form. So base 12 to the power of 2 equals all of this, 12x squared minus 12x. So that's 144. We have a quadratic, so set it equal to 0. Now quickly you should see, oh, there's a GCF of 12. So let's take 12 out. So let's factor this. Factors of negative 12 that add up to negative 1 would be x minus 4 and x plus 3. So solutions will be x equals 4 and x equals negative 3. So there are my two solutions, but let's plug them back in and see what happens. So once again, you might not have room on your notes, so you can just kind of watch this process. I will first check 4, so I'm going to plug in 4 here and here. So that would give me log base 12 of 48 plus log base 12 of 4 minus 1 is 3 equals 2. So here I can multiply. So log base 12 to condense, 48 times 3 is 144 equals 2. So is that true? Is 12 to the second power, does that equal 144? Okay, so check statement works for 4. Now let's check negative 3. So if you plug in negative 3, log base 12 of, that would be negative 36, plus log base 12 of negative 3 take away 1 is negative 4 equal 2. Okay, we have to stop there because you cannot have logarithm of a negative value. So right away, this does not work. This is an extraneous solution. Even though we did all the math correct to get these two numbers, 4 is the only true solution. All right, example number 5. We're going to look at another property of logarithms. So natural log 6y plus 2 minus ln of y plus 1 equals natural log of 2y minus 1. Now, we have two choices. So for this example, I'm going to do this choice where I'm going to condense these and turn this into natural log of 6y plus 2 over y plus 1. So if we have logs isolated on both sides, you can just set this part equal to this part. So to solve for y, we can multiply both sides by y plus 1 so that those cancel. So 6y plus 2 equals, let's FOIL this, 2y squared. Let's see, 2y take away y, so plus y minus 1. Okay, we have a quadratic. Let's set it equal to 0. 2y squared minus 5y minus 3. Okay, let's factor that. So I've got 2y and y. I need factors of -3. I'm going to do minus 3 because there's my -6. And plus 1, that would get me to -5. So then, if I set those each factor equal to 0, I'll have that y equals -1/2 and y equals 3. And for the sake of not making this video too long, I will let you know, I'm doing the math for you. This is an extraneous solution, so the only real solution is 3. Because when you plug in -1/2, you'll end up getting logarithm of a negative number, and that can't work. Okay, last example, similar to the last one, just showing you another way that you can go about it. It's about basically the same idea, just kind of showing you your variations. So natural log 7x plus 3 minus natural log of x plus 1 equals natural log of 2x. So instead of condensing these into a quotient, you could add this term to the other side. So natural log of 7x plus 3 equals natural log of 2x plus natural log of x plus 1. So now, because it's positive, you can condense these into a product. Either way, you're going to get the same answer. It's just kind of your choice, what you prefer. So 2x times x plus 1 is 2x squared plus 2x. Natural logs are isolated, so set this equal to this. So we have a quadratic, set it equal to 0. Subtracting the 7x would take me to minus 5x and then minus 3. That's actually the exact same quadratic that we had in the last one. I didn't even realize that. So 2x plus 1 and x minus 3. So our solutions are x equals -1/2 and x equals 3. But in this case, if you plug these back in, they actually will both work. So sometimes both solutions do work. It's very common when you're dealing with quadratics that one of your solutions will be extraneous, but in this case, they both work. So there is your video on solving logarithmic equations. Good luck with your lesson.